So this is some guidance for how to do the calculations on the KF lab. Let's first of all look at the equation you'll be using to find the KF of water. And it's going to be delta TF equals I KF M. Now the delta TF, that's going to be the change in freezing point. And then you've got your I, which is the Van't Hoff factor. And then we've got KF, which is what we're looking for. It's called a mole freezing constant. And then you've got M, a little m, which is the molality of the solution. Now it's molality, not molarity. And I'm going to go through and explain how we're going to get each of these things as we go through, and I'll just give you a basic preview of what you're going to see in the lab. So what you'll do is you'll start off with, well, it's going to be a solution of ice water essentially. And to that you're going to be adding sodium chloride. And it's going to be a certain mass of sodium chloride. Now this molality here, molality is defined as being moles of solute over kilograms of solvent. Now the solute here is the NaCl. So you stick that into the water, and of course it dissolves, and you stir it around a bit. So what you've got here is a solution of NaCl and ice water. Then what happens is that the ice gets filtered off, so what we're left with is just NaCl and water. Now the moles of solute, that's going to be the NaCl, and we know the mass of that. We know the mass of the NaCl, so we can get the moles of NaCl, 1 mole over the molecular weight in grams of NaCl. So that's what's going to go in here for the molality. Now the kilograms of solvent, now it's important that it's solvent, not solution. So the solvent here is water. In order to get the water, I'm going to have to do a subtraction. I'll have the mass of the NaCl solution, which will likely be given in grams, and I'll have to subtract the mass of the NaCl, which will also be in grams, which will give me the mass of water, which is in grams. That needs to be converted into kilograms, and the way we do that is we do times 1 kilogram over 1,000 grams. So make sure you always show that dimensional analysis when you're showing that work as well, and we'll end up with kilograms of water, which is what goes in here is kilograms of solvent. So that's how you're going to pick up the molality here so that we can get this KF value. Remember, we're going to have to end up solving for this. Now as far as the I goes, I is the Van't Hoff factor, and if you look at sodium chloride, NaCl, it's actually, as a solid, when it dissolves, it becomes Na plus aqueous and Cl minus aqueous. And that means since there's 2 particles here, the Na plus and the Cl minus, that means that the I value is going to be 2. So that's how we get the Van't Hoff factor, which is I. That of course will go in here. Now the delta TF is the change in freezing point. See, what you'll have to do initially is figure out the initial temperature of this ice water. So you'll have an initial temperature of the ice water. And what's going to happen is once we put the NaCl in, we can get a final temperature for this ice water. And what we're going to find is that the temperature will go down. It's called freezing point depression, and it's a colligative property that we notice, and it happens with all solvents. And whenever you dissolve something in any solvent, the freezing point will go down, and that's actually what we can measure with our thermometer. Now this delta TF here is the change in freezing point, which is going to be the difference, and it's going to be the difference between the final and the initial temperature of the ice water. So you want to find this difference, but you really want it to be a positive value. So you make it so that the delta TF comes out to be positive. So make this positive. And if you make that positive, what will happen is then when you try and sort out the KF value, you'll be able to have that come out as a positive value as well. And of course, to solve for that then, it's going to be Kf is equal to delta Tf divided by I times M. Now the unit for this is going to be degrees Celsius per molal, which is the unit for molality, which is expressed as a little m. You are also given the real Kf of water, which is going to allow you to compare the two values. The value you get here and the value for water, the Kf of water itself, which is given as 1.86 degrees Celsius per molal. Your value won't be exactly the same as that, but you'll be able to look at how close it is by determining the percent difference between the two. And the way we work this out, the percent, or say the percent error, if you will, in the Kf values is going to be the absolute value of the known Kf minus the experimental Kf. And that's going to be the absolute value there, divided by the known Kf. And that's all multiplied by 100%. Now the experimental Kf, that's what you find. That's your value. And the known Kf, which is going to be in both these positions here, is going to be 1.86 degrees Celsius per molal, or whatever value you happen to be given to the number of significant figures you're given there.